Hello and welcome. In this video, we're going to be discussing how to simplify an expression like the one you see on your screen. So before we begin with this problem, let's begin by reviewing a couple of background concepts. So the first background concept that I want to review is how we handle negative exponents. So if you look at number 1, you'll notice that I have this x to the negative second power, and then I've got y to the positive third power and z to the positive fourth power. So remember, when I have a negative exponent, it's just telling me to take the reciprocal of that base. So if I did that here, I would end up with, well, the y to the third would stay on top because it has a positive exponent. There's no reason to do the reciprocal. The z to the fourth likewise would stay on the bottom because it has a positive exponent, so I wouldn't move that base at all. But the x would actually come to the bottom because when I do the reciprocal, it's just going to flip it over the fraction bar. And then my exponent, once I've done the reciprocal, becomes a positive 2. And that's about as far as I can go. The second concept that I want to review is how we combine like bases that are being multiplied together. So here I've got x squared times x to the third. So if I multiply like bases, remember that that means the way I handle the exponents is by adding them together. So in this case I would have x to the 2 plus 3 power, which would simplify to x to the fifth. The third concept that I want to review is how we divide like bases. So you can see in the third example I've got x squared over x to the seventh. So to handle that, we're going to subtract the exponents. And you'll notice I have more factors of x on the bottom than I have on the top. So that means I'm going to have x's left over on the bottom, and all my x's on top are just going to become 1. So to know how many x's I have left over, I'm going to subtract. So I'm going to take 7 minus 2 is 5. So I'm left with x to the fifth on the bottom. On the top, I'm just left with a 1 there. Okay, so let's see how we can use these three pieces of information to help simplify the problem that we started with over here. So the first thing that I want to do with a problem like this is I want to go ahead and rewrite my expression using positive exponents. Okay, so I've rewritten my original expression, and one of the things that you should notice is that on top my base has a positive exponent. So I'm not going to do anything with this base. It's going to stay right where it is. On the bottom, this guy is going to stay put as well because the exponent's positive. The one that's going to flip is going to be this guy because his exponent is negative. So anything with a negative exponent is going to flip. So when I rewrite this using positive exponents, again, my y to the 1/3 is going to stay put, my y to the 1/2 is going to stay put, but my y to the 3/2 is going to come to the top. Okay, so that's step 1, is I'm just rewriting my expression using positive exponents. The next thing that I want to handle then is, you'll notice on top I'm multiplying y's with other y's. So I want to consolidate what I have on top a little bit. And since I'm multiplying y's with other y's, that means I need to add my exponents. Eventually, if I look down the road, I know I'm going to need to do some subtraction as well. So what I'm going to do for step 2 is I'm going to go ahead right away and make each of these exponents, which are all fractions, I'm going to make each one into an equivalent fraction so that I have a common denominator, so that my fractions are going to be a little easier to add and subtract. So step 2 is going to be to get a common denominator for each of those fractional exponents. Okay, so if I want to get that common denominator for each fractional exponent, well, I'm looking at the fractions. I've got 1 over 3, 3 over 2, and 1 over 2. So the least common multiple of 3 and 2 is 6. So I want each fraction to have a denominator of 6. So the first one, since it's 1 over 3, if I multiply top and bottom by 2, I'll end up with y to the 2 over 6. Okay, similarly for the second one, if I multiply top and bottom of that guy by 3, I'll end up with y to the 9 over 6. And then on the bottom, if I multiply that guy top and bottom by 3, I'll end up with y to the 3 over 6. Okay, so now I have fractional exponents that all have a common denominator. My third step then is going to be to consolidate the top. So since I'm multiplying y's with other y's, I'm going to add those exponents together, and now that I have a common denominator, that will be that'll be at least easier to do. So I'm going to call step 3 my consolidation step. So if I consolidate on top, if I add my exponents together, I've got 2 over 6 and 9 over 6. So if I add those together, I'll get y to the 11 over 6. On the bottom, I'm going to keep that as just y to the 3 over 6. Okay, and now I'm going to use that last piece of background information that we saw, which was when I'm dividing like bases, remember I subtract my exponents. And so wherever I had more factors to begin with is where I have x's or whatever my base is left over. So if we look at this case, notice my top has a higher exponent than my bottom. That means when it's all said and done, I'm going to be left over with y factors on top. And my bottom is just going to become a 1. So here we go. If we subtract the exponents, we'll have 11 over 6 minus 3 over 6 is y to the 8 over 6 over 1. And now all I can do to simplify that a little bit is, well, I don't even need the fraction since it's over 1. So I'm going to erase my fraction bar. And then 8 over 6 as a fraction can be reduced to y to the 4 over 3. And so my final answer is just going to be y to the 4 over 3 power. Okay, here's another problem for you to try. So pause the video. After you've given it a shot on your own, go ahead and restart the video and see if you ended up with the correct answer. Okay, so our first step with this guy, similar to the last problem, is I'm going to move this base that has a negative exponent to the bottom. Everything else is going to stay where it is. So I've got z to the 5 over 2, and then z to the 1 over 3. And then when I move that other base to the bottom, I get z to the 1 over 2. My next step is to come up with a common denominator for all those fractional exponents, which again is going to be 6. So if I take the first fraction on top, multiply top and bottom by 3, I get 15 over 6. If I look at the first fraction on the bottom, multiply top and bottom by 2, I get z to the 2 over 6. And then multiply the second one by the top and bottom by 3, I get z to the 3 over 6. Okay, then I'm going to consolidate. That's my last step. So the top's going to stay the same. The bottom, when I multiply my z's together, I'm adding the exponents, so I get z to the 5 over 6. And then I'm just going to continue consolidating. So notice now I've got z's divided by z's, so I'm going to subtract those exponents. Notice I have more z's on top than I have on the bottom. That means I'm going to be left with z's on top. The only question is how many. So if I subtract 15 over 6 minus 5 over 6 is 10 over 6. And then there's just a 1 left over on the bottom. So the only thing I can do is I can simplify that fraction. 10 over 6 becomes 5 over 3. And then since it's over 1, I don't even need to write the fraction part, the over 1 part. So my final answer is just z to the 5 thirds.